All right, so if you are joining us for the Climate Live K12 sessions for the first time, this is a video series held by the Columbia Climate School that allows us to share the research and scholarship of experts across many different centers of the Columbia Climate School to students, educators, and the public. My name is Laurel Damashihi. I am the program manager of the K12 and continuing education programs, and I will be facilitating today's session. So just in case you are unfamiliar with the Columbia Climate School or are joining us for the first time, the Climate School is a newly established school at Columbia University for transdisciplinary climate research. This school marshals the university's strengths in basic and applied disciplines, and it expands its resources to understand climate and its impact on society, develop and inspire knowledge-based solutions, and educate future leaders for just and prosperous societies on a healthy planet. So this is the first new school at Columbia in over 25 years, and it incorporates 20 different centers with over 700 people who collaborate among many different departments at the university. And through this, we are able to better connect and amplify and advance new areas of climate inquiry, research, and impact across Columbia and beyond. So with these Climate Live K12 sessions, we are hoping to introduce you all into the interdisciplinary work that is done by our scientific experts. These are monthly video series that are run throughout the entire academic year. This is actually our third to last session. Our last session will be held in June. If you'd like any more information about the upcoming sessions or any of our past sessions that are recorded, I'll put the website in the chat for you. And you can also email me, and I'll put my email in the chat as well. So each month we focus on a different topic, and it's catered for a certain age range. So for today, our session is entitled Everything You Wanted to Know About Climate Mobility, but Were Afraid to Ask. And this is led by Alex Sherbinin, a senior research scientist and associate director for science applications at the Center for International Earth Science and Information Network. This session is targeting high school students and undergraduate students, educators, and the public, but everyone is welcome to join. All right, Alex, I will let you take it away. Thank you for joining us today.
Thank you, Laurel. By the way, Laurel is a former student, so it's great to see her on screen here. So it's a real pleasure to be here. I'm going to do my best to share my screen in a way that, wait, I'm disabled, so I don't know if you can enable that. Work out that.
Okay, it should be all set now.
Excellent. So I'm going to wait, that's screen one. I want screen two. Let's see what I got here. And I'll switch. Okay, so greetings. Thank you for joining me today. I'm really excited to share a little bit about what we know about climate mobility. So you'll learn more about what climate mobility is. You'll learn more about where we might expect to see different types of mobility or migration. My own role is as Deputy Director of CIESIN, and I manage a NASA data center. You'll see some of the data sets that I'll be referencing today are actually available through our NASA data center called the CDAC, or Socioeconomic Data and Application Center. I'm a co-director of a climate mobility network here at Columbia that involves a lot of faculty and some affiliates outside of Columbia University who are all focused on research in this area. And I've been coordinating for more than 20 years something called the Population Environment Research Network. Looking forward to answering questions you may have after I'm done with a hopefully relatively brief presentation, hopefully not too boring a presentation. What is climate mobility? Why do we call it climate mobility and not just call it climate migration? Actually, for many years, I just called it climate migration. But what climate migration kind of didn't really include were things like displacement owing to natural disasters, refugee flows, managed retreat, which I'll be touching on towards the end of my presentation, which a term that's used in this field, and things like planned relocation or resettlement. I'm going to be touching today on two different contexts. I'm going to be spending the majority of my time talking about low income and low resource settings. many parts of Africa, Asia, Latin America, where people may either be forced to move because of climate disasters or displaced by climate-related hazards, or they may become increasingly immobile and trapped in locations where they're unable to really sustain themselves. And so that becomes more of a humanitarian concern. But I'll also be touching briefly towards the end in high income settings where you have more voluntary migration that may be much more indirectly affected by climate impacts. And so you'll hopefully learn by the end of this presentation that there are many drivers and that it's complex. And so it's not easy to say that climate is the cause of people moving in almost any circumstances around the world. So I asked Laurel, and she said it was okay to give a little climate change 101, in part because some of the impacts that I'll be addressing are related to these climate impacts. So I think most of you are aware about the heat trapping greenhouse gases such as CO2, methane, chlorofluorocarbons, and things like that, that essentially trap so the sun has shortwave radiation that comes into the Earth's atmosphere, and then it bounces back as long wave radiation. And all those gases tend to trap more heat around the Earth. This has led to, clear evidence of air temperature change in the higher troposphere, also over land, over oceans, increases in water vapor in the air and the atmosphere, changes in sea surface temperature, decreases in sea ice and glaciers, etc. So most of you are aware of these things. This is some data that describes the changes we've seen already since the 1950s and 60s, where temperature changes have been most dramatic over the poles, partly due to sea ice melting and other atmospheric and land ice melting, but also other atmospheric effects that cause a disproportionate increase in temperature over those areas. But really, there's very few land-based areas of the world that haven't seen fairly significant increases in temperature of between 1.8 and 3.6 degrees Fahrenheit or 1 and 2 degrees Celsius. This is largely due to the increase in carbon dioxide in our atmosphere. This is, again, mostly probably review for many of you who are interested in climate matters, but I think it's important to remember that this is what's driving the changes in our climate. So in the future, what we're likely to see is somewhere between a 1.5 degree increase in temperature in a low end RCP 2.6 world with lower RCP stands for representative concentration pathway, and it's a lower amount of warming of the Earth's surface. But with high emissions, we could see up to 4 degrees by the end of the century. So even if we reach the Paris target of 1.5 degrees Celsius above current levels, the disruptions will be quite substantial. And that means that the climate envelope in which our systems are adapted, is changing as well. So we've lived and had the benefit of a fairly stable climate over roughly 11 to 12,000 years since the last glacial period. And so what we're seeing is an increasing temperature. We're seeing increasing extremes. So this is essentially represents the kind of bell curve that you might see of temperatures over the course of a year, with most temperatures centered around, say, I don't know, let's say it's 50 degrees Fahrenheit. Now the average might be closer to 60 degrees Fahrenheit over a longer term period. And you get more of these extreme tails where the temperatures really get quite extreme. Here in New York today, it's over 80 degrees and we're only in April. So the natural variability, of course, in temperatures and in precipitation and things like that will continue to occur, but the shifts in the mean values can lead to much larger changes in the frequency of extremes. Let's look at that in terms of temperature extremes. Here you see more daily record highs in a ratio sort of daily temperature records. And it's 7-to-1 in some recent years of daily record highs to daily record lows. So there's really quite a change and shift in the number of record highs that we're seeing in the US. Also, much higher increase in the percent of the amount of rainfall that's occurring in the heaviest 1% of events. So we're seeing 40% up to 50% increases in the total annual precipitation that's occurring in the 1% highest events. That essentially means that as the atmosphere warms, more moisture can be held in that atmosphere, and it results often in these torrential downpours that we've seen an increase in. Cyclone activity is also projected to increase. So what you see here is this is probably the more interesting graph, and it basically shows the accumulated cyclone energy index. In the past 20 years or so, you've seen just an above normal intensity of hurricanes. So that's the kind of sheer force with which the hurricane hits the coastline, the wind speeds, but also we've seen much higher rainfall events and these flooding events, like in Hurricane Dorian, where the storm system simply sat over an area. Hurricane Harvey in Houston, these systems just sit and stall over a location and dump amazing amounts of precipitation and cause massive flooding. Forest fires are also on the increase, and so what you're seeing in the Western United States, and this is just for 3 states, California, Oregon, and Washington states, is a trend in increasing forest fire intensity and also area burned. So this is a measure of the number of acres burned in the Western US. You can see the trend line. So colleagues and I have been looking at the issue of habitability and what it means to be habitable. Remember, I talked about the envelope that we sit in as a society, in the climate envelope. And so if that shifts in different ways, both in terms of the extremes and the averages, you could expect to see changes in habitability in certain locations. And we define habitability as both basic human survival, so that's sort of like the baseline, just having enough food and water, but livelihood security, which has to do with ability to grow crops and fish or otherwise sustain one's livelihoods, and then finally society's capacity to manage environmental risks, which can't be taken for granted. There are unfortunately a growing number of what we call failed states in the world. These are states that really don't have the capacity to manage climate extremes and climate change, let alone many of the other day-to-day functions of government. Now, modeling can point to regions where habitability will be threatened, but there is a risk in doing this work that we become what might be termed climate determinists. Climate determinists would be people who say it all comes down to climate and it's all doom and gloom and catastrophic scenarios. And I think it's really important to realize that humans have agency, that humans are complicated. We need to be informed by social science. I myself am a social scientist. I work with many physical scientists whose work I respect very much, but we need to have an appropriate understanding of human and societal abilities to cope and adapt to these changes. We need to understand what are the core factors and the peripheral factors that are important for migration decision-making, and we need to look at potential social feedback mechanisms that might counter climate impacts or reinforce them. So sometimes we talk about social tipping points. If a community starts losing members of rural community because agricultural impacts of the climate impacts on the agricultural system surpass a certain threshold, as young people leave those communities, do they become less dynamic? Are they less able to resist and be resilient to the climate impacts that are happening? And there may be important advances in modeling that we need to consider as well. So now let's turn to migration. What do we know about migration? This is a somewhat simple summary of a complex topic, but we can think about migration as being kind of a function of push and pull factors. There's also new theories that are coming along that address how people have both the aspiration, the desire to migrate, but also, on the other hand, the capability, and how the capability to migrate may be more limited for low-income populations than it is for high-income populations. So these are all important theories that assess or seek to explain what happens when people are stressed. But if you take this sort of push-pull diagram, what you have is essentially a mix of factors at origin that are either positive, negative, or neutral to the migrant. You have intervening obstacles that relate to the cost of moving to a new location, the visa barriers, potential legal barriers, and other things such as just purely the cost of transportation, or in some cases people may need to use smugglers to get them into a country or another location. But you can use the same model whether you're looking at a country. So obviously people don't need to be smuggled into their own country. They can move from a rural to urban area relatively easily, but there still may be costs associated with setting up in a new destination. And then there's the positive and negative attributes in the neutral attributes of a destination area and the things that people might consider important in those locations. And so this is kind of simple but helpful heuristic for understanding how people think about opportunities and whether they consider options that are farther afield to be more attractive or not. And so what we see in some of the observed facts about migration is it tends to increase over time. So you can imagine if someone leaves their origin area and they have a relative, they become established in the destination area. Now the people in the origin area have a relative to whom they can appeal for help. They can get information on how they did the migration. So there's social media aspects of helping, even if you're not related to someone, you can learn about how they went about their migration and what benefits they accrued from moving to the new area. Is it tough or is it difficult to get established? Can you get a job? Things like that. That all becomes, that information flow is much more, it's reducing some of these intervening obstacles over time. Migration is also selective. It's selective in terms of the age of the migrants. Tends to be people in there from like 15 to maybe 30 at maximum. Sometimes people over 30 migrate, obviously, but there's an age selectivity. There's also sex selection, and that depends and is very regionally specific. So in much of Central America and migrants coming to the US, it tends to be more dominated by males. But what we're seeing is younger and younger migrants coming from Central America and more women, and so those dynamics do change over time. And then economic motives tend to predominate. So if you ask most migrants why they move, it's because they needed a job, they want to send money home, they wanted income, they're poor in their destination, in their origin areas, and they expect to have greater opportunities wherever they're moving. But as I said, climate factors can sometimes factor into those. And we'll talk about that a bit more in one of my next slides. There are 3 dimensions of migration: space, time, and volition. I'm not going to get into this so much, but clearly there are different ways in which migration takes place. So this is kind of a helpful diagram to help you think about how hazards on the one hand and social vulnerability. So, we can think about social vulnerability in terms of the types of households, the demographic characteristics. Are they rich? Are they poor? Do they have many members? Or they have few members? What are their strategies for making a living? Are they farmers, pastoralists? Do they have a small shop or something like that? Do they work in a company or in a small firm? These are all factors that may influence the propensity to migrate, and also the ways in which environmental hazards impact on communities. This produces risk, and then risk can influence population mobility, but there are these different things that come and intervene that may cause the migration response to be either increased or decreased. So if the government has a good, let's say, early warning system or disaster management system, they may be that community may be more protected and less likely to consider the need to move. Are there insurance, payouts that could be available? What are the past experiences with migration as a risk reduction strategy? What are the availability, other types of responses, et cetera? All these things can affect whether people are displaced, or they go into some kind of permanent migration, or they temporarily migrate and then come back again in a circular form of migration. And these all result in feedbacks that affect the locality in terms of their social vulnerability. So you can think of migrant remittances as a way of enabling communities in the source areas to remain in place, because the migrants are able to send money and support those people. So that could reduce their social vulnerability to disasters. As I mentioned, the environmental factors generally tend to work through economic things like agriculture, but also wages. There's pretty good evidence that that climate factors can impact industry across the board and affect different sectors of the economy, not just agriculture. But there's also ways that environmental factors work through political dimensions, conflict and insecurity. There are ways in which environmental factors could affect demographics. And so all of these elements are kind of classic. These 5 corners of the pyramid, or the hexagon here, are different elements that are known to influence migration decision-making. And then there's a lot of personal characteristics that play into whether someone decides to migrate or stay. Age, sex, I mentioned some of these demographic elements, but also intervening obstacles such as political and legal frameworks for migrating, cost of moving. I think we've covered a lot of these things in the prior slide. So is there actual evidence for climate change-induced migration and displacement? What does the research tell us? There's a lot of media headlines these days that suggest that climate change is going to result in massive waves of migrants coming to the shores of the US and Europe, or that it'll result in a massive refugee crisis. And what does the evidence show us? There are a number of ways to get at this question. I'm not going to cover in detail the first one, but this is really like looking back in kind of prehistory and understanding analogs for changes in population distribution and migration as a result of past climatic events. There's also studies that look at more recent historical events, such as the Dust Bowl in the US or the Sahelian droughts, and analyze how those played out and resulted in redistribution of population. I happen to have been working in the Peace Corps during the second of the 2 Sahelian droughts, so I'm that old. I actually was around when the 1980s drought was occurring, and I remember seeing many dead carcasses of animals on the ground, and crops had withered. And then by the time I was approaching my first year of really being in the field working as a volunteer, the rains returned, and it was completely changed the context. And there was abundant rain-fed agriculture, and people were happy again. But it was a really trying time for many people, and it resulted in a lot of people moving to urban areas and slum areas of the urban areas of the Sahel. In the Sahel, meaning West Africa, meaning the region that I was working was a country was called Mauritania, but it's on the Senegal and Mali borders, and so that was in a region that I was particularly familiar with and understood in more depth. Other approaches to understanding these relationships have to do with using census and survey data and very careful statistical analyses to understand when you control for all the factors that might contribute to migration, such as the age and sex and education of the people, job types, et cetera, what is the marginal effect of climate factors on migration, and how do those how does that climate influence tip the balance one way or the other in terms of propensity to migrate? And then finally, evidence from, there's been evidence from displacement from extreme events or climate deviations. So this is a little bit like the historic record. So people that I work with at Lamont Doherty Earth Observatory, for instance, some of them are involved in doing dendrochronology, and this is piecing together the climate record from the past and looking at the thickness of the tree rings to understand periods of drought versus periods of abundant rainfall. There's ancient texts, and there's historic sites and archaeological sites where people can assess essentially what's happened in the historic period, and get a better sense of whether it coincides with periods of abundance or collapse for those societies. More recent environmental events include things like the U.S. Dust Bowl, which resulted in 1 million people leaving the Midwest, Oklahoma in particular, but Texas Panhandle, going to California, settling there. At one point, the dust plumes from the Great Dust Bowl in the 1930s went all the way from that area that I just mentioned to Washington, D.C., and that's what kind of woke up lawmakers to the fact that they needed to do something. And in fact, they also invested massively in something called the Soil Conservation Service, which was a way of preserving the land and ensuring that these kinds of dust bowls wouldn't occur in the future. So one of the things to be aware of in that context was it wasn't just the drought. There was a drought, but there was also really intensive crop cultivation in areas that really probably should not have been cultivated at that level. So they took advantage of a period with anomalously high rainfall, and they did a lot of cultivation and whatnot, and that land then became prone to dust, to windblown dust, and so it was a really catastrophic event. There are other more recent events, such as droughts in Brazil and droughts in the Sahel, and both of these tended to result in mostly internal migration to cities, and labor migration and things like that. The careful statistical analysis, this is just one of many examples that have been done where people have looked at things like the propensity to move in Mexico from rural areas to urban areas as a result of changes in heat months. So this is the increase in the number of heat months over 50 months in which successive months where heat is above average, or one standard deviation above average, and you get a migration response that increases over time as those number of months accumulate. In drought months, it's just simply linear. It goes up over time, and the number of drought months increases, the number of migrants moving out of rural and into urban areas increases. Some of the data that we have on internal displacement is shown here, and what we can see is that natural disasters tend to dominate over conflict and violence, but there's ups and downs by year, and many of these natural disasters, if you look at the pie chart of natural disasters, they are generally about 80% climatic in nature. So things like cyclones, landslides, extreme rainfall, floods, etc. So this gives you a bit of a snapshot of the trends over time, but what we have seen is a great increase in the number of internally displaced populations over time. This is an example of one of those somewhat sticky or complicated situations where there's both a combination of drought. So Syria had a massive drought in the late 2000s, from 2007 to 2010. It's the worst drought in the instrumental record. meaning instrumental record means historic record, the record in which we've actually been measuring these things. It caused widespread crop failure and mass migration of farming families to urban areas. And the question then became, and these are some colleagues here who worked at Columbia University, as well as some others, is did the drought potentially help contribute to the conflict in Syria? And there's been widely varying views, but I think the sense is that it certainly did not make matters any easier in Syria prior to the major conflict that occurred from about 2010 through 2015. And of course, it also triggered massive outmigration and refugee flows from Syria, and really woke Europe up in some ways to the fact that mass migration could really impact both their societies and reach many of their shores, but also the politics in Europe, which have become increasingly centered around nationalist, anti-migrant. There's a mix, obviously, of people within each society, but there's a big uptick in the number of nationalist and anti-immigrant groups in many countries of Europe, and of course, we've seen the same thing happen in the U.S. So I guess the question is the threat of climate refugees just media fear-mongering? One thing that I think needs to be stated up front is the much larger fraction of migration that's going to occur will be within countries and within regions where low-income regions. So there'll be a very small fraction of people who will potentially move longer distances to places like the US and Europe. That said, as the large numbers of people are, as larger numbers of people move in general, that fraction becomes a larger number of people who could potentially be seeking to migrate. Again, climate is not the major reason, but it's in the mix of factors that could be contributing to moves, what we call increasingly distressed migrants or mixed migrants. These are flows of migrants, such as the migration caravan that came out of Guatemala, where large numbers of people join those caravans for safety reasons in the transit. And you could see in those flows of migrants, both people who were potentially displaced by major climate events, such as the hurricanes Eta and Iota, but also economic migrants and others who are fleeing gang violence and complicated situations in their home countries. So getting back to the evidence, yes, I think environmental change has contributed to population movements in the past. It's going to continue to do so in the future. People are moving primarily to ensure income, but that's also under sometimes adverse environmental conditions. Rural and urban migration has increased in many countries because of environmental changes. Environmental change can influence future displacement and migration. We'll get into modeling the future in a moment. And then there's this real risk of many people being trapped in locations where environmental conditions deteriorate and their livelihoods and their situations decline. I said most migration will be internal or south-south between countries. In the global south, temperature and precipitation both explain migration patterns. And so their effects, however, vary from place to place, which again sort of accentuates the and underscores the reality that it's usually very context specific, based on culture, based on policies, and based on economic drivers that movement occurs. And finally, there will be likely some future resettlement and planned relocation as a result of climate impacts. This is a paper we wrote for Science a few years ago, in which we talked about really it's one of the first papers that appeared in 2011 on the subject of the potential need to resettle populations. So quickly going through what the future might look like, there have been a wide number of estimates of what the future migration impact could be from climate change. And they've been everything from back of the envelope estimates to basically what I would call exposure estimates, saying if so many people are going to be affected in a coastal area, and you just draw a line from the coast and say This is the elevation zone in which people will be likely inundated. Therefore, those people will need to move. That's another way of doing it. Sometimes they do it with drought or desertification. They kind of look at how many people would be affected in those areas and assume that a certain number or a high proportion of those people would have to leave. So these were very back of the envelope ways of doing things. What we sought to do as a team at Columbia is to partner with the World Bank a few years ago and produce some at least defensible estimates of future climate mobility. And the premise behind this work was that in many parts of low-income countries, that people who live in off the land, essentially, is the simplest way of saying it, are likely to be more heavily impacted by climate impacts and more likely to potentially choose migration as a solution if their local livelihood is endangered. You know, obviously there's efforts afoot to adapt to changing climate, and that's many of those efforts are actually being led by Columbia as well as many other universities and country institutions in the global South. But in the absence of some of those adaptive responses, we could face situations in which people are facing increasing levels of risk. So this is a diagram that shows on the x-axis the intensity of adverse impacts from various types of disasters and the frequency of adverse impacts. And so the worry is that as you know, let's say temperatures increase and this affects rice yields or maize yields or what have you, that the livelihood security of smallholder farmers will be endangered, and that many of them will potentially need to move away from their farming livelihoods into other sectors. We modeled this using a gravity model. I won't go into the methods, but we came up with what we feel are somewhat defensible estimates of migration of between 48 million and 216 million people internally migrating by 2050 in these regions, which are World Bank regions that are mostly low income. The largest numbers will be in Africa, and also the highest sort of proportion of the population that would be affected would be in Africa, suggesting a high climate sensitivity in that region. And the numbers are lower so you can see these bars, and you can see the height of the bars represents the total number of migrants. So in a more inclusive development scenario where people really are, you know, there's higher levels of education and higher levels of GDP, there's reduced migration owing to climate impacts, and the lowest levels are in a future with much lower levels of emissions, which is the RCP 2.6 scenario. So this was, you know, some summary results. We were able to map this as well. So for instance, in China, you see movement of climate migrants towards the coastal areas and away from areas that are inland and more isolated and generally more arid. In Africa, you see some movement towards border areas in northern Nigeria, parts of Angola as well. And a lot of these hotspots are in areas that are particularly highly populated, such as the Lake Victoria Basin. We did more recent modeling for the Africa Climate Mobility Initiative, and you can see here the URL, which you may want to visit for the actual data visualization part of this, because it's a really interesting project and they did a very nice job visualizing the data. But what we see is clusters of high mobility and immigration in areas around Nigeria, Ethiopia, Sudan, etc. And you can see some of these one by one in this map. So I'm going to close with a few slides just describing what we might see in the US context. So what we're likely to see is increasing storm surge and sea level rise in many coastal areas. This is the share of homes in really high-risk flood zones, and you can see Africa, I'm sorry, my brain, Florida, really popping off the map here, and some other places like Louisiana with very high percentages of homes in very high flood risk areas. Drought will be another factor. What we're seeing more recently, of course, in California and some of the Rockies is replenishment of water supplies. But they said that the historic droughts that we've had over the last decade were so severe that even with the extensive rainfall and snowpack in the Rockies this year, it's still not going to be enough to fully replenish those water supplies. So they seem to be swinging in a way from deficit to surplus. But I think it's going to be more of these kinds of extremes instead of the happy median that we've seen in the past. In terms of extreme heat, we see projected a number of hot days above 90 degrees Fahrenheit in this map, with, again, Florida kind of popping off the map with really high numbers of days above 90 degrees Fahrenheit. And then wildfire risk is another factor that's going to be important in the future. So these are some articles that occurred in the New York Times, appeared about, climate migration in the US. Colleague of mine, Jesse Keenan, actually was behind this article about Duluth, Minnesota as a possible migration area. I actually have friends who moved to New York City from Duluth. So there are people leaving Duluth, believe it or not. But they were sort of saying this could be an area that's water abundant and actually provide a kind of refuge for people seeking to flee fires in the American West. That may be the case, but as Jesse points out, most of the information about this is highly qualitative, highly anecdotal, and so far we don't have enough data to prove that there's any trend. In terms of past US migration, we did some modeling for the Foresight report, which I cited earlier. And what you see in the US is that unlike most other regions of the world, so if you just focus on the blue bar here, which is the US, is that there's a lot of net migration into dryland ecosystems, meaning this American Southwest, into mountain ecosystems. And also there's some migration into coastal areas, but that's dwarfed by the amount of migration in Asia and other places in these coastal areas. So really what the US sort of has an anomalous pattern of movement into areas that are typically considered to be relatively marginal or high risk. This shows the net migration rates for 2000 to 2010. And you can see a lot of depopulation of the Midwest and then some parts of the South and Southeast, but large movements into these really arid areas of New Mexico, Nevada, et cetera. And also a lot of in-migration into areas, very high-risk areas in Florida. So what we're seeing is trends that are not necessarily positive in terms of the future. These are some data that we distribute through our NASA Socioeconomic Data and Applications Center, and they show different scenarios of population change in the US out to 2050 projected. And so these are changes in population from 2020 to 2050. And depending on what scenario you look at, SSP1 is a highly developed, very highly economic, like a lot of agglomeration and movement to cities, and you see more concentration in cities. This is a scenario where we restrict migration very heavily in the future, so the growth is not as high as it is under this scenario, which is a scenario with much more open borders and very expansive growth beyond just the cities into other parts of the US. You need a scenario-based approach to look at the future because that's the only way to really assess the uncertainties that we have in peering into the future. This is an example of some work that was done using machine learning, which is all the rage, looking at what might happen to migrants leaving the 1.8 meter sea level rise climate affected counties in the coastal zone, which are all in blue, and where they might move based on past moves in the future. So, up to 1 million people moving into some of these darker shaded counties. We've been looking at managed retreat at Columbia, which is a pattern to this conference, which I just skipped over, but is in late June, if you're a college student or even a high school student really interested in these topics, I strongly suggest that you join us there for that conference. I think there's some discounted rates for students, and the issue then becomes things like, if a disaster occurs, where do you do buyouts, and how do you pay homeowners for homes that are now routinely being flooded out or routinely being affected by high tides? What are the kind of optimal scenarios for future migration out of certain areas? And there are certain case studies around the U.S. that show situations where residents want to move, and there's general societal benefits from them moving, and so that's really an optimal scenario. But for many cases, they have to do it on their own, basically figure things out. That's what's happened in parts of Alaska, and there's other less optimal scenarios. There's a lot of equity issues that have to do with past redlining. Redlining being a form of discrimination in home loans that occurred throughout much of the 20th century in the U.S. Communities of color tend not to benefit from things like home buyouts as much as other communities, white communities. And then there's been these historical biases and forced relocation of indigenous communities. I'm not going to go into all the policy options for managed retreat, but it's a very technical area in terms of how the U.S. is addressing these issues, how other countries are addressing these issues, and tends to be less spontaneous and more, in high-income countries at least, it's more of a policy and kind of incentive structure that allows people to move out of areas that are high risk and hopefully into areas that are lower risk. But as I said earlier, the natural tendency in many cases is for people to move into areas of high risk. So that's a problem that we have as a society. Okay, summing up, I think I've stated all these things hopefully clearly, but climate change and variability are already affecting mobility, including longer term migration, not just seasonal migration or displacement. Most climate migration and displacement will be internal. People will migrate for a large variety of reasons, and society and institutions, frankly, are fairly ill-prepared to meet these challenges. So this is not an issue that is just isolated to low-income countries. I think there's a tendency in the US to say, we're safe, we're fine, no problem. But even countries with very robust infrastructure and who are economically better off and functioning institutions are going to be challenged by many of these things. So with that, I'd like to close and give you my thanks for your attention, and I look forward to hearing your questions in the Q&A period. This is how you may contact me if you would like to email me with any questions individually. Thank you.
Thank you so much, Alex. Just a wonderful presentation. I do want to invite everyone to use the Q&A to ask questions now. And I also have a few questions, so I can kind of kick it off while we wait for folks to populate that Q&A. So
Sure.
I found it really interesting, the map that you had shown of China, that you were saying that there were large populations of folks that are living in more rural areas, moving toward the coastline, probably because they're experiencing drought and they might be farmers. Are they not concerned with the threats of sea level rise along the coast?
Yeah, so this is another example, I guess, of movements that may be suboptimal from a longer term perspective. So the economic opportunities in China are definitely in the coastal areas. What I want to be clear about in that map was the areas that were in blue inland are movements that are additional beyond what we might expect from just normal development processes. And these are additional owing to climate impacts. So what it suggests is that our climate models are projecting increased, say, drought or effects on crop production and water availability in those regions, and that the climate models are suggesting more favorable situations in the coastal zone. many of the coastal areas that were in that map are not immediately in the coastal zone. So they're far enough back that they'll be fine, and they're not going to be necessarily affected by sea level rise and storm surge. But it does beg some questions. I think the evidence that we gathered and we in our modeling work for the Foresight project suggested that there are many parts of the world where movements will be potentially into more climate risk areas. You can imagine a rural farmer leaving central Nigeria and going to Lagos, which is right on the coast and barely above sea level, and living in a small, in a settlement, a low-income informal settlement there. And that can present many issues for flood risk and for housing security. And but often they choose to live in those areas because they're close to their work, or they have more economic opportunities. So there are trade-offs. See, there's some questions in the Q&A now.
Yes, perfect. So yeah, I mean, you're absolutely right. I just wanted to say, like, there are so many other variables than just climate, you know. Anyway, Dennis has asked, I was afraid to ask, but then I read the title of this talk. So how difficult is it for scientists to deal with politicians, many of whom are climate change deniers?
Yeah, fortunately, I don't run into too many deniers in my work. And so, and especially in low-income countries, people are already seeing, the politicians are already seeing the impacts. They're aware that this is a big issue. And so now in the US context, as I said, I haven't directly interacted with too many deniers. But one of the things that I think is important to recognize is that even many deniers, they kind of understand or know that there's real risks that that the society is facing. But you know, they have some vested economic interests that may cause them to sort of say, I don't want to admit that this is really happening. And I think if you can kind of get beyond that maybe knee-jerk reaction and just talk about observed changes and what we're seeing already happening, they can kind of come around and understand that this is real. I think in some ways, in my line of work, the greater risk is that you play into hands of nationalist politicians or others who claim that there'll be mass migration as a result of climate change, and so we need to do more to reinforce our borders, or put up barriers to migration, and that's very difficult and complicated. I think that that's a longer conversation, but I'm not, I think that we try not to play directly into the hands of fear mongers in this area. What are the works that measure the impacts of adaptation and mitigation? Well, that's a good question. In this particular area, the modeling we did does incorporate mitigation. So we have model scenarios that project a future world where greenhouse gases are reduced greatly according to the Paris Agreement. And we see, and not because we game the model or otherwise try to make it this way, but the modeling work actually shows that that there are few people on the move. And so that's, one effort that we've made to kind of incorporate mitigation. What we have not done in our modeling work is to model different worlds with potential adaptation scenarios. And so things like irrigation works in certain parts of the world, or increase afforestation activities to plant trees. And there's an effort in Africa, in West Africa, called the Great Green Wall, which is controversial and in some ways may not succeed. But in other areas, we've seen already efforts to reforest areas that have yielded great benefits for soil and water conservation. And these have been driven by the farmers themselves rather than some top-down effort. And those efforts could have fairly dramatic impacts on local livelihoods and result in fewer people desiring to move. but to actually model how those adaptation interventions will interact with local societal processes is challenging.
And I saw Clara had her hand up for just, oh, okay, here we go. Dennis asked another question, but Clara, if you have a question, feel free to use the Q&A. So Dennis asked, it appears you read The Worst Hard Time by Timothy Egan. My mother made me read this book. She and her family had moved from Kansas to California in 1935.
Yeah, I know of the book. I haven't read it, but I read another account of the Dust Bowl, and it was it's a cautionary tale, right? And as I said, it's not just climate, it's land management, it's a whole range of things that resulted in a pretty calamitous situation for people involved. There was a lot of speculation, land speculation, banks involved. You know, these things inevitably become fairly messy. And so, yeah, I think the Dust Bowl is still, some of the data from the Dust Bowl are still being analyzed by colleagues. There's a colleague, Robert McLemmon, who's one of the leaders in this field, and he looked at how soil fertility affected the propensity to migrate from different parts of Canada. Now, he's a Canadian, and he's focusing on the Canadian Dust Bowl era, which was around the same time, but he found that actually soil fertility was a strong predictor of whether people moved out or not. And so richer, stronger, and better soils resulted in fewer people moving out. So it's an interesting finding. How do you factor in cultural, economic, technologic-driven waves in that? Yeah. Yeah, really, this is a really interesting question. Thank you for anonymous attendee for putting that up there. One thing that we know is that any effort to model the future is going to be prone to very high uncertainties, and there are things. Let's just look at could we have imagined in 1975 that the breakup of the former Soviet Union would result in massive outmigration from from Russia and other countries that were part of the Soviet Union? Probably not. And similarly, could we imagine? Can we fully imagine all the future scenarios in the world that might result in massive displacement or migration? I think, frankly, we cannot. So what the modeling purpose is not so much to predict and say we know what's going to happen by this time so we can plan accordingly, but it's to provide plausible boundaries around what might happen and start to think about additional factors, such as you suggest, that might result in changes in the future. Now, I haven't looked at the past and how climate might have, overlaid on these other things related to slave trade or colonialism and things like that. But what's clear is today, a lot of those historic diasporas and changes have legacies, and the legacies that they have are resulting in climate vulnerability and risk in regions that are generally the least responsible for those climate impacts. So one article in particular that I would commend to people is one by Carmen Gonzalez, a Loyola law professor from Chicago. And Carmen Gonzalez examines the issue, the history of racism and colonialism from a climate migration lens, and I found it to be one of the most enlightening articles that I've read in recent years. So with that, I think I have to close. But Laurel, over to you with any final parting words.
Yeah, I think that was a great question to end on. Thank you all for joining us. I think Alex had shared his email, so if you do have any questions, it seems like you would be open to answering them offline. And if you have any questions for me, my email is learn@climate.columbia.edu. We have another Climate Live session happening in May, the second Wednesday of the month. We look forward to joining you then. And Alex, thank you so much for joining us.
Thanks again. Thank you all.
Bye, everyone.
Bye now.